Peter again. Welcome to part 3 of my edge finding made simple. I subtitled it A Bit of Fun because in fact that's what it is. It's only vaguely connected with edge finding, but I think you'll find it interesting. If you don't, you can switch off. Right, now I probably need to move the camera. Perhaps I won't. Now, that is a sine bar. I showed that to an engineering firm, friends of mine in the village, called Maytime Engineering. And there's 2 people there, father and son, and lots of people who work for them, obviously. And they do all CNC stuff, which is quite beyond me. I'd love to learn a FANUC one day, but not very simple. The son, Neil, didn't know what it was. Bernie, the father, who's just over 80, knew what it was straight away. And he recognised it as a sine bar, and he knew what to do with it. Now, I made this sine bar myself. It's 2 pieces of silver steel with a long piece of milled square stock, and with slots cut in it. And before we go any further, I need to show you a diagram. The slots, by the way, are exactly 150 mil apart. I made it myself, by the way. You can buy them from MSC for only a few quid, but there's no fun in buying things ready-made, is there? I like to make things myself. It's got 2 socket cap screws which secure the pieces of silver steel in there, and they're counterboard, so they're down below the level of the interesting later on. Now, if you take a right angle triangle, that's one where that is 90 degrees, and that angle there we've called A, then that is the perpendicular, and that is there is the hypotenuse, long name for a bit that joins those 2 bits together. Now, the sine of the angle, sine of angle A, is P over H, that distance divided by that distance. Now, the bit that you use to raise the sine bar up to generate a particular angle, that bit there is actually called the sine bar riser. But what we're going to do today is not to set out a particular angle very accurately. We're going to use the test piece that we used in part 1 and use that as the riser, like that. I hope you can see this. Maybe I ought to adjust the camera slightly. And then we will have created an angle, but instead of using a known riser to create a known angle, we're going to do it in reverse. We're going to use the test piece in part 1 and measure the angle, which will then be able to determine the length of the test piece. Yes, I know we know what the length of the test piece is because we measured it in part 1. This is why I've called it a bit of fun. It's really only just that, a bit of fun. We've got to measure the angle, and to do that, I'm going to use a digital protractor. Now, that is only accurate to point plus or minus 0.1 of a degree, so we won't actually achieve a very accurate result. Once again, why I called it a bit of fun. Now, obviously we can't do it on here because you need to set it out on a surface plate or something that you know the flatness of, and for that reason I'm going to do it on the table of the mill because that is absolutely flat. So let's go over to the mill and play with that. Right, I don't know whether you can see this or not, but that is a digital protractor. I've put the sine bar up on there and I'm going to measure the angle. Now the first thing you've got to do is to zero it. Like that. Having a bit of trouble here. Right, I've done it. Now, if you can see that, it now says 0, because before it was set out to read the angle from gravity. Now it's reading the angle from my mill table, which is actually quite close. So we're going to put that up on there like that and take a reading. And then I'm going to go away and work the whole thing out. I'll bring you back when I've done the maths. Right, I am now sitting at the welding table again, and the angle we measured was 50.4 degrees, and the sine of that angle is 0.7705, and if you multiply that by 150, which is the length between the rollers of the sine bar, you get 115.575, and the actual measured length was 115.730. So it's very close, bearing in mind that the digital protractor is only accurate to plus or minus 0.1 degree. Well, I think that proves the point. That really brings us to the end of this edge finding made simple. I know the last part wasn't really very simple. It involved mathematics and God knows what, but I hope some of you at least have found it interesting, and maybe you'll watch my next video when it comes up. Thank you very much for watching. Bye.